In this video, I'm going to share with you the 5 most important things you need to know about statistics so that you can get the most out of your data. So, the first thing you want to remember about statistics is that it is all about the data. Statistics is, in fact, a branch of mathematics, but it is a branch of mathematics that deals specifically with the collecting, the analyzing, the summarizing, the organizing, and the presenting of data. And so when you are doing statistics, you want to remember that your job is to identify the type of and the quality of the data so that you can determine whether this data is suitable for further analysis or not, and even as we'll see later, what type of analysis can be done. And so when you're doing statistics, you are setting the foundation for the data analysis, the data science, the machine learning, and all of the artificial intelligence that will be done using data, because the quality of the data will determine the quality of the data science that you do with it. And so the second thing that you want to remember about statistics is that it can be used to make very important decisions, right? When you analyze your data and you get the information about the trends and the patterns in the data, then you can use that information to guide your decision making. So you can tell what is trending, what is going to be needed, what types of products are being sold at at what season, and who is buying it. And so those are the kinds of decisions that then you can be making without guessing, but being informed by your data. So data helps you to make informed decisions, and this is just not in business, but in medicine, in architecture, in agriculture, in almost every field now that you can think of. Data is being used to guide the decision making of stakeholders. And so that's what statistics allows you to do. The third thing you want to remember about statistics is that there are lots of statistic tools, but you have to make sure that you are using the right tool for the type of data as well as the type of analysis that you're going to be doing. And so when you are assessing the quality of your data, you bear in mind that it is going to be used to answer certain questions and to test certain hypotheses. And so you want to make sure that the test matches question and the question then matches the data. There must be congruency. And so it's important for you when you're doing your analysis, and even when you're evaluating other analyses that have been reported, you want to look at whether the data type matches the research question, not just the type of data, but in terms of the quantity of data. Here we have the number of variables. So it's quantity as far as horizontal, how many columns, how many characteristics we have in our data here. So these columns would represent the characteristics, and also how many rows, right? How many observations, how many individuals make up this sample data set. And so you want to get an estimation of the size of your data set. Then the second thing that you want to, it's categorical, in this case, different professions, or if it's numerical, here we're looking at income. So if it's income we're looking at, that's going to be a different type of test, a more regression type. If it's categories, then we want to do a classification type of statistical analyses. And so, again, we have to think about the design of the study, what it is that we're trying to do. Are we looking for trends here, or are we trying to, if we're looking for trends as far as the data set is concerned, any kind of relationship among two or more variables, or we're doing some kind of classification or grouping or segmenting of our data. The fourth thing that we want to remember when it comes to statistical analyses is there is a difference between the population data and the sample data. And there are different things that you can do depending on what kind of data you have. So if you have population data, of course, you have the entire set of information that is available about the trends and what's happening, changes, characteristics in your data. So, for example, if you want to say look at whether all the math teachers in the state of Ohio, what kind of makeup that is. So you have the entire population, you have data on everyone. So you have what age, gender, their educational characteristic, educational qualification, how long they've been teaching. So you have the entire population, and you can do analyses on that. But if you don't have all the entire population, then you just have a sample. You can then get some group characteristics from that sample and infer some characteristics to the population. But you want to make sure that your sample is indeed a random sample. And when you think of random sampling, think of it like you're making a pot of stew and you want to get an idea of how much salt it has. You can just take a small teaspoon and taste it, and that will give you information about the entire pot of soup. Similarly, with the random sample, you can use a random sample to give you information about the entire population, but you must make sure that and you select randomly so that nothing is influencing the choice of the individuals that gets incorporated into your sample data set. You want to remember that the population is for the entire set of information available, and you can get trends from that and patterns. But the sample is just a subset, and it is supposed to be a representation of the population data. And you can get some insights on the group, but you always want to be mindful of the fact that that is an estimation and that there's some error associated with that. The fifth thing you want to keep in mind when you are either performing any kind of statistical analysis or you are evaluating is that you want to make sure that your results are trustworthy. Right, you want to avoid bias as much as possible. You can't get rid of all the bias types of analysis, but you want to minimize it as much as possible. And just like I talked about, making sure that if you are using a sample, that the sample is random, so that every segment of the population gets a chance to be represented in your sample. Survey data or reports tend to be very popular, right? People make these surveys, especially around election time, and then they report the findings. But it tends to be very biased. It tends to be biased in favor of people who, one, have telephones, because that's how the surveys are conducted, and two, people who actually answer their telephone. So that's some of the things you want to consider when you are collecting your data for your analysis. The performance of your analyses, they want to make sure that you avoid sloppiness, view your analyses several times to make sure that there are no mistakes made, no oversights, no errors. Even get a second person to perform the analysis. Then there's issue of blindedness. This is one of the ways that in the field of statistics we attempt to reduce bias, right? So we try to blind. It's either double blind or single blind. Double blind meaning both the researcher as well as the participants don't know which group they belong to as far as the control and the experiments are concerned. So, we divided the people into two groups, and one group is going to get the experimental treatment, whether they're going to see the new website or get the new drug or whatever. That'd be the experimental group. And then there's a control group who, they're not going to get anything. But to get blindedness, we don't let them know what they're getting. So in the case of the experiment, we give the sugar pill or the placebo to those who are not getting the actual drug, so that nobody knows, so there's no that bias as far as receiving a drug is concerned. And then even the experimenter or does not know which group is which, so as not to bias their interpretation of the results. So that's one of the things you want to bear in mind, and if you can, to make sure that that's happening in your own data setup as well as in the collection of your data. And then you want to make sure all your devices and instruments are actually working properly, collecting the data as they should. And so those are some of the ways that you can help to make sure that your results are trustworthy. So you have a clear plan for the collection of your data, the who, when, what, why. Establish what the research question or the research objective is beforehand, so as not to have the results be influencing what you're looking for. And then once you have the clarity on that, then you want to make sure that you're also testing your instruments to make sure that they are collecting, correct, precise, and accurate data measurements as much as possible. Again, it goes back to the quality of your data, because that's going to be the determine the quality and the trustworthiness, the reliability of your results. Once your data is collected, you have performed exploratory data analysis, right? So you want to look at your data, you want to summarize the data, you want to evaluate the data in terms of the mean and the mode, and all those kinds of basic descriptive statistics, as well as looking for any kind of anomalies and to establish whether the data is normally distributed or not. And so these are the things. And then when it comes to choice of data set, exploratory data analysis is what's going to help you decide what is the best statistical analyses or tests to use on your data in particular. Once you have done that, you can now establish some kind of standard to make sure that everyone in the team knows and understands the what and the why of good quality data. So at the end of your experiment, at the end of your analysis, everyone is not just necessarily happy with the results, but they were happy with the process, the way that it was carried out. And you can be proud of the data science and the statistics that you have performed, because you know that it is going to stand up to the rigor of any other data scientists or statisticians. Okay, so those are some of the five things, in my opinion, that I think are important for you to remember to get the most out of your data. And so the first thing you want to remember is that statistics is all about the data. The quality of the data will determine the quality of your analysis. Secondly, you want to remember that statistics is used to make important, informed decisions. So you want to you want to apply sound statistical principles, because your data analysis is going to be used to inform very important decisions. And the third thing you want to remember about statistics is that the type of data determines the type of statistics you will perform. And you need to look at the number of variables, number of characteristics, that you have in your data set. Then you look at the type of data or the level of data, whether it's categorical or continuous, and whether that categorical is, ordinal or binary, and then whether the continuous variable is, whether that numerical variable is continuous or it is discrete. And then the fourth thing that you want to remember is you want to remember that there is a difference between the population and the sample data. And so when it comes to population data, that can be used to identify the trends and patterns. And then the sample data is used to get insight about the group behavior. You can then use the sample data, if it is a random sample, to make inferences about the trends and patterns in the population. And finally, when it comes to ensuring that your data is trustworthy, you want to have a collection plan, make sure your instruments are working properly, and that you perform the right type of exploratory data analysis, and that everyone involved has a good understanding of the what and the why of good quality data. So go forth and use these wonderful tools and get the most out of your data.